In this video, I'll be going over how to find the empirical formula from the percent composition. This is example 311 from your textbook. You can read it here. The first step in this type of problem is to set up a table. And on that table, you need to have the column headers of element, mass, atomic mass, moles, mole ratio, and whole number ratio. So our elements in this are phosphorus and oxygen. The next step is to put in the mass. Now you're given the percent, so assume that you have 100 grams. The sample size doesn't matter as long as the relative amounts are correct. So if you had 100 grams, you would have 43 grams of phosphorus and 56 grams of oxygen. Then the next thing that you will need to do is to calculate the number of moles of each element. In order to do that, you need to know the atomic mass, which can be found on the periodic table. So for phosphorus, this atomic mass is 30.97, and for oxygen, it's 16. Then to find the number of moles, divide the mass by the atomic mass to get the number of moles, which is 1.409 moles for phosphorus and 3.523 moles for oxygen. Now you need to get the mole ratio. To get the mole ratio, you're going to divide each number of moles by the smallest number of moles. So here you can see that you have 1.409 moles of phosphorus, 3.523 moles of oxygen, the smaller of those being 1.409. So divide each one by 1.409 to give you a mole ratio of 1 mole of phosphorus to every 2.5 moles of oxygen. Now this needs to be in a whole number ratio, and so the lowest whole number ratio would be to double each of those, which would give you 2 moles of phosphorus and 5 moles of oxygen. This is the smallest whole number ratio, which is also known as the empirical formula. So the empirical formula for this compound is diphosphorus pentoxide. Now let's look back at the original problem and note that we are looking for both the empirical formula and the molecular formula. So the equation for this is that the empirical formula mass times some whole number is equal to the molecular molar mass. In other words, the ratio of the molecular molar mass to the empirical molar mass is a whole number. This is also true for the empirical formula using the same ratio. So let's calculate this now. You're given in the problem statement the molecular molar mass of 283.88, and you can calculate the molar mass of the empirical formula to be 143.96. So plugging that into our equation, you get 1.97 as the ratio. Now, anytime this ratio is within 0.05 of a whole number, you can go ahead and give it the whole number that it is closest to. So now you can use that whole number of 2, multiply the empirical formula times that to give you a molecular formula of tetraphosphorus dectoxide. That's it for now.